Quantum superposition is a fundamental principle of quantum mechanics. It states that, much like waves in classical physics, any two or more quantum states can be added together or superposed, as the result will be another valid quantum state. And conversely, every quantum state can be represented as a sum of two or more other distinct states. You can think of superposition as a system that has two different states, and it's possible for it to exist in both. In physical terms, an electron has two possible quantum states, spin up and spin down. When an electron is in a superposition, it is both up and down at once. It is a complex combination of both. Only when it is measured does it drop out of superposition and adopt one position or the other. An example of a physically observable manifestation of the wave nature of quantum systems is in the interference peaks from an electron beam in a double-slit experiment. The pattern is very similar to one obtained by a diffraction of classical waves. So basically, this is what and how superposition works. Now, let's look at one of our favorite topics, that is Schrodinger's cat. In quantum mechanics, Schrodinger's cat is a thought experiment that illustrates a paradox of quantum superposition. It was devised by Austrian-Irish physicist Erwin Schrödinger in 1935 in a discussion with Albert Einstein to illustrate what Schrödinger saw as the problems of Copenhagen interpretation of quantum mechanics. The prevailing theory, called the Copenhagen interpretation, says that a quantum system remains in superposition until it interacts with or is observed by the external world. When this happens, the superposition collapses into one or another of the possible definite states. In this thought experiment, a cat, a flask of poison, an internal monitor, and a radioactive source are placed in a sealed box. If an internal monitor, that can be anything like a Geiger counter, detects radioactivity, that is, a single atom decaying, the flask is shattered, releasing the poison, which kills the cat. But the Copenhagen interpretation of quantum mechanics implies that after a while, the cat is simultaneously alive and dead if no one sees it. But when one looks in the box, one sees the cat either alive or dead, not both alive and dead. This poses the question of when exactly quantum superposition ends and reality resolves into one possibility or the other. In simple terms, this is the definition of quantum superposition. In 1957, Hugh Everett formulated the many-words interpretation of quantum mechanics, which does not single out observation as a special process. In the many-words interpretation, both alive and dead states of the cat persist after the box is opened, but are decoherent from each other. In other words, when the box is open, the observer and the possible dead cat split into an observer looking at the box with a dead cat and an observer looking at a box with a live cat. But since the dead and alive states are decoherent, there is no effective communication or interaction between them. When opening the box, the observer becomes entangled with the cat, so observer states corresponding to the cat's being alive and dead are formed. Each observer state is entangled or linked with the cat so that the observation of the cat state and the cat state correspond with each other. Quantum decoherence ensures that the different outcomes have no interaction with each other. The same mechanism of quantum decoherence is also important for the interpretation in terms of consistent histories. Only the dead cat or the live cat can be part of the consistent history in this interpretation. Decoherence is generally considered to prevent simultaneous observations of multiple states. So these are all the basics you would have to know about quantum superposition and Schrodinger's cat. Next time on Discover Zen, we will be discussing quantum tunneling. Thank you for watching our video today. If you liked what you saw, please give us a thumbs up and subscribe. Let us know in the comments below what you think of quantum technology.